This is the Gravitational and Electric Fields Homework Booklet, questions 1 to 3. The first question is very straightforward. Which of the following statements about Newton's law of gravitation is correct? Now, the law of gravitation is summarised using this equation, and here you can see that it explains how the gravitational force depends on the variables included in the equation. If you are asked to state this law, you should say that the gravitational force is proportional to the product of the masses and inversely proportional to their separation squared. This separation refers to the distance between two point masses, or if they are not point masses, you must measure to the centre of mass of each one. The next question is using this equation, and here you find a diagram is quite helpful to summarise the information given. So we have a spacecraft at the midpoint between a planet of mass m1 and another planet of m2. We are given this distance as d, and it follows that the other distance shown must be the same. Key point here, you're asked for the magnitude, so size only matters, of the resultant gravitational force. Key word here is resultant. Now, you could look at the options available to you and probably very quickly come to decide that it must be B or C because of the d squared on the bottom line. Then, thinking more about the meaning of resultant, we would have two forces acting on this mass, and they're in opposite directions, which is why we end up with the negative sign in answer C. A fuller calculation is shown here. Finally, probably the most challenging of these three questions. Again, summarising information given in a quick sketch. We have a space shuttle in low orbit, and it is affected by the Earth, the Moon, and the Sun, and you are required to correctly put the order of each of these gravitational forces. Now, how you do this question might depend on the time available. You have got all the numerical data to do a rigorous comparison between all three forces using the equation. If you were pushed for time, I think you probably could very quickly realise that it must be answer A or C. We would expect the gravitational force due to Earth to be the greatest because the satellite is in orbit around the Earth. That leads you then to compare the gravitational force due to the Sun and the Moon a little bit more carefully. Here we have to play off two factors that impact on the size of the force. We have the Sun of greater mass but much further away, and we have the Moon of smaller mass but much closer. The most important thing is really to think about the powers of 10 and how they impact on these variables. I've set out the calculation for the ratio of the relevant mass to the relevant separation squared. The g and the mass of the satellite, they're obviously constants, so they would not have an impact in terms of the relative size of these forces. So mass of Earth divided by the distance from the Earth squared, mass of the Sun divided by the distance from the Sun squared, and mass of Moon divided by the distance from the moon squared. You could calculate a numerical answer for each of these three sums if you wanted to. A slight shortcut is to focus on the powers of 10. So 10 to the 24 divided by 10 to the 6 squared, that gives you 10 to the 24 divided by 10 to the 12, which would give you 10 to the 12 as you subtract these powers. Doing the same thing for the sun and the moon gives you a power of 10 to the 8, and for the moon you have a power of 10 to the 6. So since these are different enough, you probably could be confident that this is now the correct order. If these two were closer, then you might feel you've got to deal with the whole number in your calculator. So the final answer is answer A.